So again, just like with IgE, we see that there are common antecedents, triggers, and mediators. With the underlying concept, again, to bring home is intestinal permeability. So this is a slide we've showed before. What are the triggers of intestinal permeability? These triggers lead to this mediator of altered intestinal permeability. We're looking at specifically here this increased uptake of food antigens, and then immune activation, inflammation, systemic disease. Tom Sold and Tom O'Brien showed this slide yesterday. I'm highlighting it again because of the importance. I have actually this slide that I use as a handout when I talk to patients about increased intestinal permeability and why I'm suggesting an elimination diet or a medical food, etc. So I use this handout quite a bit. So here's another nice diagram from a peer-reviewed journal showing you that first, as I've noted, there are a lot of things that change those tight junctions, and second, that we're not making this up, that there's quite a bit of research that reports that food plays a role here. That was a 2008 study, and the idea that food can cause increased intestinal permeability and lead to systemic complaints is not really new. Naturopathic physicians have been talking about this for decades. And it's not just anecdotal, there's scientific support. This is early 2000s. This is a 2006 study that they used what's called lactulose mannitol, or urinary test for the ratio of lactulose mannitol. And what they said was, and they reported that intestinal permeability as measured with this lactulose mannitol ratio was present in all subjects with adverse food reactions, not just food allergies, which supports the idea that other things are going on with food reactions unrelated to conventional reactions to food. This is a more recent study. This was done a couple of years ago. This is what's called confocal laser endomicroscopy, in which they look microscopically and visualize changes in the intestinal wall after a food challenge. And so what they did in this study is they found really these dramatic changes, and these are changes in that paracellular between the cells. They showed dramatic changes in those breaks in those between cells, and so this is essentially showing increased intestinal permeability. And they showed that almost 2/3 of patients who had IBS symptoms challenged with certain foods had these dramatic structural changes. And more importantly, when they removed those foods from the diet, they saw good correlation with clinical response. So patients reported improved symptom scores by 50% at 4 weeks and 74% at 12 months. So it's important to note here, I think, that not all the foods caused reactions in all the subjects. There were 36 subjects. There were about 2/3, or 22 out of the 36, showed reactions to food, some more than one. Not all individuals with IBS are going to show a reaction to food, but in this particular study, and I think my clinical experience supports this, a lot of individuals that have gas and bloating and these symptoms of IBS have reactions to food, but not all. So it's individualized. So not everybody with IBS had a reaction to food, but in here 2/3 did. This is just a follow-up study by the same group in July of 2019 that revealed the same kinds of results, and they called these reactions, what they said, they were non-classical food allergy, or IgE negative reactions. And this is what we call food sensitivities or possibly intolerances. So it's very likely, I think, in that CLE, in those studies, that this non-classical food allergy reaction are IgG reactions. And it's important to understand here, again, the difference between IgE and IgE and IgG, and why IgG reactions are more difficult to assess. They don't generally cause symptoms immediately or necessarily as dramatically as IgE. So a headache or a migraine might happen 2 or even 3 days after eating the food. The onset is delayed, and therefore patient awareness can be low, but the antibody can be significantly decreased, as I say here, in a matter of months. So unlike IgE, where the antibody is generally around for years, if not lifelong, and therefore the reaction generally stays for years, if not lifelong. Since you can decrease those antibodies, you can decrease the response to that food often, and sometimes you can reintroduce that food in small amounts and tolerate it, which is another, I think, important distinction between sensitivity and allergy. So what kinds of symptoms are associated with IgG hypersensitivity? Well, there are many, they're varied, and IgG reactions are really all over the place physiologically, as you can see here. So the old adage of, what goes on in Las Vegas stays in Las Vegas, that's the opposite. What goes on in the gut doesn't necessarily stay in the gut. So there are a lot of reactions, and I think of IgG foods hypersensitivity as the great masquerader. It can masquerade as a lot of different things because you can have reactions all over physiologically. So there are, in the past 15 years, a number of studies that have validated IgG testing. This is probably the first one that I've seen. This was in 2004. It was a study on IBS patients. With the sham diet versus a true diet, they had some improvement, statistically significant improvement of 10%, and then those who were stayed compliant longer had even more improvement. So the value increases as the compliance increases. That led to a number of studies on IBS. And here is a year later, and as was pointed out in that article again, the higher the adherence, the greater the improvement. Here is a 2008 study entitled Time to Reconsider the Clinical Value of Immunoglobulin G4 to Foods. Most laboratories are now doing immunoglobulins 1 to 4. There was a time where some labs would do, and some still do, just immunoglobulin 4. I think most labs are doing all the immunoglobulins, but this was support in this study, an IBS study. 80% of patients had symptom improvement and their IgG antibodies decreased. Then there have been studies through the past few years on IgG and migraines. Specifically here, this is a 2010 study that showed positive efficacy in migraine attacks, and another positive study in patients with migraines and IBS, and this study was in 2013. And this is the same paper that I showed you before by Dr. Aristo Vijani. This is a bigger blow-up of that schematic that I showed you. And the takeaway here, and I think related to migraines, is that a leaky gut can lead to a leaky brain through the process of inflammation. That's what he's talking about here. Now, there have been other studies. There's been a negative study. This one actually was published a few years ago and was well publicized and criticized, or was, I should say, well publicized, IgG and ADHD in kids, and it was negative. What was interesting was that they used an elimination diet and actually showed very positive results. Everybody went on an elimination diet, and then they also took their blood and tested for IgG antibodies, but they didn't show on re-challenge a correlation with IgG, and I'm going to come back to this and talk about this because I think there's a caveat to why this particular study would be negative. Here is supporting references, of the research that I showed you, and my point here is now there's a body of research which supports this type of laboratory evaluation for food sensitivity testing. So there are some issues there with IgG testing. Probably the biggest issue or the biggest challenge is as I mentioned, in contradistinction to IgE serum testing, there's no standardization in the industry for IgG testing, so there will be inter-lab variation. Each lab uses its own antigens to test, and therefore you really have to use the same lab over and over again and you have to be comfortable with that lab and perhaps do a split sample to look at coherence, or as I say, there may be some analytical limitations around split samples as well, but you really need to be comfortable with the lab and use the same lab. So third, there's immunoglobulin subclass deficiency, that's fairly rare, and then the same for IgE, that there's interference with steroids, etc. So you wouldn't want to use it if somebody's on oral steroids. This doesn't mean we shouldn't be using the testing. We should just be using it and have a realistic open mind of what it's good for and how useful it is. If you haven't used this kind of testing, here's what a result would look like. You can see, you can test really any number of foods. Many of these panels are 90 foods or 180 foods. I have generally, not always, but generally started with a smaller panel of about 20 foods. It's more economical, and it gets the patient engaged with the idea that foods can cause reactions, and we can measure reactions other than IgE when they come in with negative IgE tests, and that those reactions can be shown essentially on laboratory data. Here's just another IgG report that you can see and how they set it up. So testing and treatment, some important points I want to stress. One, a positive test result indicates only the presence of antibodies specific to that food. It doesn't necessarily mean clinical symptomatology. That means it's not a perfect test. That again is the idea of sensitization and threshold. Same with IgE that I discussed with IgE. But I'm doing this test. If I'm doing this test, I'm doing it on somebody I am suspicious of, so I generally exclude any food with any level of sensitization because there's some question as to the relationship between higher antibodies and symptoms. And that's getting back to that ADHD trial that I suggested. So in that trial, they took these kids, they put them on an elimination diet, they took their blood, they tested for IgG foods. They found that a very positive response, ADHD symptoms went down. And then what they did is they re-challenged with high antibody titer foods and low antibody titer foods, and they didn't find any difference in that re-challenge. In other words, they weren't able to say, oh, those high antibody titer foods that they re-challenged, you got more of an exacerbation versus low antibody titer foods. So, I think, and so they called that a failure, but to me, that just suggests that all foods that show a reaction may cause symptoms. Therefore, again, I generally remove all the positive responses. So 2, eliminate reactive foods for at least 4 weeks to assess improvement. Again, I talked about 4 weeks, the half-life. Therefore, the circulating antibodies go down by half, which seems to be enough in many people to see improvement, at least initially. That doesn't mean they're not going to improve more, and Dr. Bischoff will talk about how long you may want to do that over time, because I think you will see more positive results as well. So 3, if the test shows reactions to many foods, consider this thing, intestinal permeability. So it's not always the food's fault. It's increased intestinal permeability from perhaps a plethora of different sources, and you need to treat that increased intestinal permeability. And here, I think I'd like to point out that sometimes perfection is the enemy of the good. Dr. Bischoff will talk about, and when I take somebody off of food, I try to have them 100%, but if they come back and they have been 95% successful, often they're getting positive results, and that's likely because we are improving intestinal permeability. And certainly in celiac disease, there's something you want to eliminate down to the milligram amount, but in food sensitivities, it may be a total load effect, and I think mostly it is likely it's a total load effect. If you improve intestinal permeability, you can often improve their sensitivity to those foods, and then you may be able to have them reintroduce those foods and do all right with smaller amounts of that foods. So then the last point is response may show an exacerbation before an improvement. So by a show of hands, how many of you done an elimination diet on your patients? Just raise your hand. Okay, so maybe about half or over half. And do your patients have adverse reactions? Some patients have adverse reactions, and then the question is, when do they have adverse reactions? Well, if they're having adverse reactions in the first 2 to 3 days, those adverse reactions may be because you put them on this elimination diet, you've taken them off coffee, off simple sugars, they're having headaches, they're having a lot more gas because they have a lot more fiber, so that's the immediate kinds of reactions. If they're having a reaction in 5 to 10 days, that's likely has to do with the next slide, which I've hidden just for time, but it has to do with antigen excess, equivalence, antigen immune complexes, and antibody excess. And there you will, I think the bottom line, again, Dr. Bischoff will talk about, is that you may, in a number of your patients, expect some sort of reaction. It's not a healing crisis, but you may get a reaction in 7 to 10 days, and you should have some expectation. I certainly don't try to say, oh, you're going to have a reaction, but you may expect a reaction in 7 to 10 days in a significant proportion of those patients that you take off that food. So you should be prepared for that. So now I want to talk about this thing we call celiac disease, wheat allergy, and non-celiac gluten sensitivity. Here is dermatitis herpetiformis. This is what that looks like. Gluten can manifest as an immunological disorder, an allergy, an autoimmune disease, and apparently as a food intolerance as well. So there's a lot of different reactions to this complicated kernel of wheat. And we know that many, at least in the United States, Americans feel that following a gluten-free diet is important because of general health reasons, or they think they're having a reaction, and more people are avoiding gluten. So statistics are a bit hazy on how many people are avoiding gluten, but this was a study that came out in 2017, said 25% of Americans follow a gluten-free diet. Many of those Americans don't know what a gluten-free diet is, so they don't actually know what they're following, but we're talking about 75 million people. We're talking about a lot of people that think for one reason or another that gluten has some serious consequence for them. Maybe they personally experience it, or they just think not eating gluten is more healthy for them. So, and then I must have hidden the slide, but there's probably in the United States these days, or actually around the world, gluten products are a $10 billion industry. So it's a huge industry, and so there's a lot of parts to a gluten-free diet. So let's look at this, what is an apparently many-headed hydra. And so just like our food reaction schematic that I showed before, this is a schematic of gluten and wheat-related disorders. So I've divided that again in two broad areas. Again, immune-mediated, so you can see the immune-mediated allergies, celiac disease, and we'll talk about non-celiac gluten sensitivity as an immune-mediated reaction. And then we talk about other that other group, which is non-immune mediated, and I talk about FODMAPs and other wheat-related disorders that I'll talk about in a moment or two. So they still involve, they may involve gluten, they may involve wheat. When we're talking about FODMAP, it's generally involving the carbohydrate in wheat. the fermentable carbohydrate that falls into that category, but there are other non-immune intolerances to gluten and wheat. And in 2012, with all this controversy around gluten, there was a group of researchers that developed a series of definitions called the Oslo definitions for celiac disease in related terms. You can see them there. And now, even just, was 2012, so 7 years later, there is now some suggestion that non-celiac gluten sensitivity, NSGS, overlaps with this thing that has now been called non-celiac wheat sensitivity, and there are various other mechanisms that may account for some of the intolerances to gluten or to wheat or to other parts of that, to parts of the wheat kernel that are intolerances. I show you this here. It's getting a little bit in the weeds. For now, I want to stick to the bigger picture. And so let's talk about, again, this schematic is just about gluten and wheat. So let's talk about immune-mediated reactions, and let's talk about allergies. So allergies are food allergies or respiratory allergies. And this is IgE-mediated. That's what an allergy is. And it can be done in both those food or respiratory allergies. And so how prevalent is that? Probably about 0.5% to 1% of the U.S. population or the worldwide population here, and then maybe a little bit less in this study in 2014 for the U.S. population. So we're still talking about a significant number of people, and we've already discussed how to assess for food allergies. So we discussed how to assess for a wheat allergy. So how about this thing called celiac disease and other autoimmune disorders? So that's gluten, ataxia, dermatitis herpetiformis. Let's talk about that. There are symptomatic and potential, as I talk about there, or as I show you there, and I'll talk about that in a minute. And so what we know now, our understanding of the immune response to gluten is improving and clearly, as Dr. O'Brien alluded to, and I'll talk about Dr. Fasano, who is on the forefront of this. Our understanding of the pathogenesis of celiac disease has really improved dramatically over really the past 30 years. And with this improved understanding, it's clear that we don't just have improved detection techniques, but we actually have an increased incidence of celiac disease over the years, and I'll show you a chart in a moment. So that is what I'm saying with better detection is resulting in more people being diagnosed, but more people are developing the disease. So studies about 50 years ago suggested it was a rare childhood condition. 1 in 1,000 children. It was, pathognomonic of this failure to thrive, anemic child. But frozen samples that they froze 30 years ago and now are evaluating showed that the incidence about 30 years ago was 1 in 400, and this trend has actually continued, as you can see on the left-hand side. It is in certain populations somewhere around 1 in 100, certainly with Northern European genetic descent. And so it's 4 times more common than it was 30 years ago. And as you can see on the right-hand side, all age groups are increasing. So why are we increasing? Why is this increasing? And Dr. O'Brien touched upon Dr. Fasano's work, and he wrote this seminal paper 10 years ago that Tom talked about. And Tom showed this slide, the takeaway, intestinal permeability, a leaky gut, is a necessary precursor for celiac disease, and he postulated that autoimmune disease in general. So in a nutshell, there appears to be this is the primary reason that there's an increase likely in autoimmune disease in general, but certainly specifically in celiac disease, is we have more increased intestinal permeability in our population. And therefore, getting back to the same thing that I've been talking about, reducing that leakiness can potentially have an effect on the incidence of celiac disease, but also various other autoimmune diseases as well. The key point here, again, to reinforce what Dr. O'Brien said, he expanded it out, but I think the three things are this trigger for CD to develop specifically, and by extension, autoimmune disease. You need the trigger, you need a genetic predisposition, and then you need increased intestinal permeability. You need a leaky gut. So basically, everyone with celiac disease, greater than probably 98%, have one or both of these genetic variants, HLA-DQ2 and DQ8, the gene variant, but a third of the population, as Tom said, carry that gene and will never develop celiac disease. So to develop an autoimmune disease in general, you need one or more gene variants, and there's at least 50% of the adult population has some gene variant in general for an autoimmune disease. For celiac disease, as I said, about 30% have that predisposition by carrying one of these two gene variants. And while the incidence is rising, only about 1% at this point actually develops celiac disease. So gene variants are a risk, but predisposition is not predetermination. It's what we wash over our genes, if you will. And so it is complex, but it's clear that a leaky gut, which is a mediator in some other complex signals that Dr. Roundtree talked about, the complexity of the immune system, turn on gluten to make gluten the trigger in that cascade that we call celiac disease. So why are these weak gluten-related disorders increasing? There's a lot of possible reasons. Modern hybridization, increased consumption, increased use of chemicals and pesticides. The gut microbiome is changing, as we've talked about, increased environmental and allostatic load. There are all sorts of reasons. We actually talk about this in a webinar in the GI module, and we talk about it quite a bit. There's a lot of background information there, but there are reasons. Not everybody has agreed on those particular reasons, but there clearly are reasons why it's increasing, aside from just this idea of increased intestinal permeability. Yet for all that we know about celiac disease, for all the press and all the popularity or notoriety of gluten, 90% of patients with celiac disease still haven't been diagnosed. And there's some statistics that it takes going to 9 different physicians, at least in the past, to get diagnosed with celiac disease. So if we say there's about 300 million people in the United States and about 1% have celiac disease, that's 3 million people. So something like 2.7 million people are walking around with celiac disease and they haven't been diagnosed. So the vast majority of celiac disease patients are undiagnosed. We see the diagnosed as that small group in red, the larger asymptomatic, which I think is a misnomer. Asymptomatic, if you have IBS symptoms, if you have, as Dr. O'Brien talked about, perhaps just osteopenia, if you have various other vague symptoms, that could be celiac disease, and that's quote unquote asymptomatic, but we have to have a fairly high index of suspicion given the fact that we know a lot of people are undiagnosed and they're walking around with problematic villus atrophy. And so potential celiac disease is DQ2, DQ8 positive, 30% of the population. They have normal villi, they haven't developed celiac disease, they have potential, but they likely, most of them will never develop celiac disease. Okay, so while we definitely know that gluten is a necessary trigger in celiac disease, the question is gluten itself a trigger for everyone to develop a reaction? And genes are not. So we heard Dr. O'Brien talk about that gluten does create some kind of inflammation. Dr. Roundtree also talked about that. But is it a toxin like lead or mercury that is just toxic and we should just all be avoiding it? And so the question, I think that's an open question. what did Dr. Alessio Fasano say in the book that he wrote a couple of years ago? And so I want to quote from him directly. And he said in the orange here, I am now convinced that our immune system mistakenly interprets gluten as a component of a dangerous bacterium or bacteria. When this happens, it unleashes an immune response similar to that triggered by bacteria to rid the body of attackers. This response is elicited in everyone. It is not exclusive to people affected by gluten-related disorders. So I think everything that Dr. O'Brien and Dr. Roundtree said goes along those lines. So what Dr. Fasano also said, he said, although I have contributed to the discoveries of some of these inappropriate immune responses elicited by gluten in humans, I do not share the position of the proponents of a gluten-free world. We engage daily in a war with many dangerous bacteria, but rarely do we lose this battle, which is an event that leads to infection. We are also engaged in a daily confrontation with gluten, but only a minority of us will lose this battle. These are the genetically susceptible individuals who will develop gluten-related disorders. So what we're talking about is that gluten is not necessarily bad for everyone all the time. What we're talking about is developing tolerance. And I think the question is how many people really have a symptomatic reaction to gluten. And we'll discuss that shortly. And here I share Dr. Fasano's perspective that to take a more nuanced view of gluten. I don't think that we have the research that suggests that everyone should avoid gluten and gluten-containing foods, and really more importantly than what I think, that's what Dr. Fasano thinks. Now, I showed this slide, or a similar slide to this, what Albert Einstein said. He said, make everything as simple as possible, but not simpler. And so I'm concerned sometimes when we want to move anything to black and white, but here, gluten to black and white, a short declarative statement makes things easier, but for gluten, that moves beyond really what we know about it in the research.